Dear students, good afternoon, everybody. Firstly, I will introduce myself, Professor S.H. Chaubey, working as assistant professor in electrical engineering department of S&D College of Engineering and Research Center, Yeola. So, we are seeing now, just in the last lecture also, we have seen the half-wave doubler circuit. Right? We have seen the half-wave doubler circuit. So, it means the voltage is going to be doubled. Not exactly the same due to time constant of capacitance and that one, that the voltage is somewhat less than that V output is equal to less than 2 Vs maximum. But it is near about where doubling the voltage that is available. Now, in the last lecture, in this lecture, what lecture? Last lecture, what you see? Half wave. Now, in this case, full wave doubler circuit. Now, components are same. Components are both in the cases half wave and whole wave doubler circuit. Components are same. There is no difference in component. Only thing that their construction or their placement is different. One is placed where, other place, D2 is placed other way, C1 is placed other way, and C2 is placed at the other way. There is going to be the difference between that. Otherwise, it will be same. The components are same. See here D1, D2. Here is the waveform of the input voltage. What happened when in full wave the components are the same as that of half wave doubler? Just I have told you that. But difference in the circuit as shown below. In the same of what we have seen the diagram of the half wave doubler circuit and see the diagram of full wave doubler circuit. The diagram is going to be saying that there is a placement of the components are different. Otherwise, the components are same: D1, D2, C1, and C. Now, what happened in this case? In the doubler, right to the positive cycle of the AC voltage, the first D1 is conducting state. D1 is conducting. What happened due to this conducting state? C1 is going to be charged to a fully Vs maximum voltage. That's going to be Vs maximum. In this case, what happened for the D2? D2 is in the reverse bias, right? D2 is reverse bias. See here, it is going to forward bias. It is going to be reverse bias. See here in this case. At this forward bias, that is forward bias, it will be charged the connected capacitor C1. Just I have told you, C1 equal to fixed value of AC secondary voltage of transformer Vs maximum. And at this time, just I have told you that at this time D2 will be reverse bias condition and non-conducting state. Throughout the negative cycle of the AC voltage, the second diode D2 will be forward bias and the second capacitor gets charged. In the negative of cycle, first positive of cycle, what we have seen, D2 is in the reverse bias condition. So C1 is charged because D1 is forward bias. Fully charged is Vs maximum. You know what happened in this case? Now in the negative cycle, the second diode D2 is forward bias. So what happened? C2 is fully charged. What one? C1 is fully charged. See here, there is going to be Vs maximum here. Here, this is going to fully charge when the positive of cycle, when the D1 is in the forward bias condition. Now, when the C2 will be fully charged, when the D2 is going to be forward bias, that is going to be in the negative of cycle condition. See here, Vs maximum. What is the output? 2 Vs maximum. This is a very simple construction and very simple theory for that one. Nothing more. Firstly, when the positive of cycle, D1 is the conducting state, so C1 is going to be fully charged. But D2 is in the reverse bias condition. But when in the negative of cycle, D2 is forward bias, so the C2 is going to be fully charged. See here, that is going to be Vc maximum. So we are getting the output voltage. That is going to be double of that input voltage. That is going to be Vs maximum. So it is called as a full wave doubler. Construction is Components are same, only they are placed in different places. You see here, that is going to be the output waveform, 2 waves maximum. See here, only pi way output, DC equal to 2 BS maximum. That is going to be the, nothing more, simple. Construction is very simple, nothing complication. D1, D2, C1, C2, how they are placed depending upon their usage as a half wave doubler circuit or a full wave doubler circuit. Otherwise, the components are same. Now, advantages of what is the voltage doubler circuit's advantages? The advantage is that can replace the expensive and heavy transformer. What transformer is going to be used? What type of transformer is going to be used? To increase the voltage level. You know, step down and step up. Step down means output voltage is less than the input voltage. But a step up transformer, output voltage is more than input voltage. It can be replaced by a voltage doubler circuit. Negative voltage can also be created by reversing the polarity of the connected diodes and the capacitor. So sometimes negative voltage will be required. And at this time, by reversing the polarity of the diodes and the capacitor, the negative voltage can be also obtained in this case of voltage doubler circuit. This is not possible in the case of transformer. Not possible. And the third one can increase the voltage multiplication factor by cascading the similar voltage multiplier. See here, when we are starting the generation of the high voltages and the current, then this time what we have seen? Cascading. Cascading, it means one is connected to second, second is connected to third. Same thing is going to be here. Can increase the voltage multiplication by cascading the voltage multiplier or voltage doubler. Cascading gain, you can increase the output voltage. That is our aim. What is our motto? What we are seeing? Generation of high voltages and the high current. Now remaining is going to the application. Where is the application of voltage doubler? The application of the voltage doubler includes iron pumps, television CRT, X-ray system, copy machine, radar equipment, traveling wave tube etc. Traveling wave tube etc. So this is going to be the, up till now what we have seen. In the case of, we have seen, in what case? In generation of high DC voltages. Firstly, we have seen half wave rectifier circuit. Then what we have seen full wave rectifier circuit. Then again, half wave doubler circuit and the full wave doubler circuit. In the remaining lecture, we will see what is the remaining portion of this generation of the high DC voltage. Okay, thank you everybody.